that should get us recording. And so the very first question I have for you is if you have a chance to take a look at the video that I posted for you for today, where I looked at kind of developing, specifically, we're developing the formula for I2. That's going to be the important bit of information that we Okay, so I haven't really gotten any answers from you guys about whether or not you're able to watch that video. Did you have any questions about that video? If you did happen to watch it, if you do, if you want some clarification, maybe I'll just do a quick little recap of the video. So the video looked at really how to deal with equivalent interest rates. And the reason we need to deal with equivalent interest rates is sometimes we get annuities where the compound structure is different from the payment structure. So the hard part about dealing with a generalized annuity is getting these structures to line up. We need the compound structure to be the same, essentially, as the payment structure. Otherwise, we get this kind of discrepancy that you see in the top example. And so the real key is to utilize the I2 formula. And I want to just work through a couple examples today, just trying to get us used to, trying to get us used to doing this calculation, get us used to the calculator, and so on and so on. I did add a little bit of information about where some of the continuous compounding cases come from. You don't really need to know a lot about the continuous compounding cases, but we may have to use the effective interest rate, maybe on test number 3 or on the final exam. So just be mindful of that. Typically, we use the effective interest rate and the formula for I2. That's typically the two formulas that are going to be on the formula sheet for you guys. And then we took a look at just revisiting that example, showing that when we did match up the compounding frequency with the payment frequency so that they were both monthly, then the future value formula gave us what we wanted. So that is posted in the video if you guys do want to go and have a quick little peek at that. My goal today is to kind of set us up with some more examples like Fiona's suggesting here, so that we can see how to work on some of the algebraic solutions, as well as kind of get a little bit more familiar with how our calculator works. Okay, so in our first example, we are going to, looks like we're going to place $400 into an account every month. That account's going to earn 5% compounded monthly. How long would you like to save up this money for? How many years do you want to save? 5 years it is. We're going to do that for 5 years, and we would like to determine the future value of this payment stream. Okay, so that's question number 1. And we're going to solve this in 2 different ways. So what I like to do on my page is just maybe divide this in half. And we'll do the calculator on one side, and we'll do the algebra on the other side. And so like we were talking about on Monday, the very first thing you want to do when you know it's an annuity kind of question is determine what kind of annuity you're working with. So I'm looking for keywords. So at the end of every month, I make a deposit, an equivalent payment. So this gives me information right away that I'm dealing with an ordinary annuity because payments are happening at the end of the month. The other important information is the compound structure. So I know the payment structure. The payment structure is 12 times per year. And I also know information about the compound structure, which is 12 times per year. So what does this tell me? What kind of annuity do we have based on these two structures? So yeah, because they're 12 and 12, we call this a simple annuity. So in other words, I know that it's simple. I know that I don't, for example, need to calculate I2. There's no need to do that because both of these structures are the same. Both of these frequency numbers are the same. So this is a simple ordinary annuity. Okay, so you do want to get into the habit of checking these things before you really even do any work. So if you have your formula sheet with you, or if you have easy access to your formula sheet, we're just going to go and we're going to grab the future value from the ordinary annuity section. And our future value looks like this. It's the payment times a fraction, 1 plus I to the n minus 1 over I. And so now we can go back through the question, try to fill in some of the variables that we need to fill in. So I'm going to start working away at that. So our payment size is $400. And we have 5% compounded monthly. So for our periodic rate, we're going to take R and divide by F. I do have to do that in the denominator too, so just be mindful of that. Now, the last thing we need is we need a value for n. So we need to figure out how many equal-sized payments we have all together. So what's going to be our power here? What's n equal to? So 5 years, every month. Yeah, so 5 times 12. Yep, I'm happy with that. So 60 should be our value for n. Okay, so we've made our substitution into the formula. Now it's a matter of just kind of plugging through this formula on our calculator and seeing what pops out on the other side. So if you guys end up getting a future value, just throw it up into the chat and we can kind of verify our responses here. Okay, so I am able to verify your final answer, Laurel. That's what I get as well. So $27,202.43. Yeah, so that's the final answer we're looking for. Make sure you're able to set up and execute that. Yeah, work that time. That's awesome. Make sure you're able to set up and execute that and get in this neighborhood, right? You need to be within a couple cents of our 43 cents. Okay, awesome. So Alexander can verify as well. So I have a feeling that if all three of us were able to get that answer, I feel pretty confident that that's probably the number we're looking for. Okay, so it doesn't hurt to get a little bit of practice with the calculator as well. So let's verify our final answer here by using the calculator. So what numbers would we have to input into the calculator's functionality in order to verify this future value? Well, we've done a lot of the calculations needed already. So for example, we've already calculated that n should be 60. We have a 5% compounded monthly interest rate. We have payments that are happening every month as well. Let's assume that we don't really start with any money inside of our account, so that the present value is 0. And then it sounds like we're putting money into the account. So I'm going to interpret that as a negative 400. Yeah, nice. So those are the values that I get as well. So let's program that into the calculator and see if we can match up our future value, make sure that these numbers match up. So this is a nice way for you to double check your work. So if you are going to use or are going to, let's see. I guess yours is a little bit different because you guys are working in an online environment. So I would probably venture to say that knowing how to program the calculator is more important. But if you did want to double check your work for any reason on the final exam, you have the capacity to essentially find your answer in 2 different ways. So you have the capacity to verify, make sure your final answer makes sense. And perfect. Yeah, I end up getting, I can verify that answer. So it looks like we were able to verify that answer using the calculator's functionality. So 27,200 to 43. Okay, so everything looks good on both sides. We were able to verify that both of those calculations look good. Okay, so that's a nice little review for Monday, right? Dealing with what we call the simple case. Let's take it up a notch. Let's see an example that's, I would argue, a little bit more challenging. Some might even say that the simple case is just too simple for you, Fiona, right? Just too simple. that was a bad dad joke, I'm sorry. So let's take it up a notch. And let's work with something a little bit more complicated. There's a little bit more happening here in this second example. So in example number 2, our bank is going to allow us to purchase an annuity for $50,000 right now. So the fair market value today of the annuity is $50,000. Now the bank is going to allow the money that's being held to earn 4.5% compounded monthly. The payment structure is quarterly, so we're going to get equal sized payments every quarter at the end of the quarter, and that's going to happen for the span of 4 years. So we'd like to figure out the size of the equal sized payments. Alexander, yes, so we have 4 payments per year and 12 compounds per year. So yes, those are the important things we need for the calculator. So as you saw, if you looked at the video portion that I wanted you to take a look at today, is that the calculator is very, very nicely set up to deal with this problem for us. It deals with this problem relatively easily. But recall that the first thing you should do is you should kind of reread the example and try to understand what kind of annuity you're working with. So I'm going to go and I'm going to highlight the important information. We need to know the compounding structure. We need to know the payment structure, and we need to know when the payments happen. So we have monthly compounding, quarterly payments, and payments at the end of the time period. So this is an ordinary annuity because payments happen at the end, but this is going to be a case where we do need the I2 formula because our frequency structure between the compounding and the payments are different. So this is a general and ordinary kind of annuity. And typically, if I was in your position in an online class, as soon as I see the word general with regards to annuity, I would go automatically to the calculator. So let's actually do the calculator part first. And then I'll show you how you could work through the algebra to verify your answer if that's something that you wanted to do, or if that was something that was asked for you. So let's see, what do we know? We know that the interest rate is 4.5% compounded monthly. So the frequency number 12 is going to go with CY. Our payment structure has a frequency value of 4 quarterly. And we know that we can walk into the bank and we can purchase this annuity for $50,000 today. So the principal value is $50,000, and we need to give that money to the bank. So I'm going to interpret this as a negative $50,000. We're trying to compute the payment size. What do you suppose the future value of this annuity will be in 4 years? I'm going to assume that after 4 years of these equal size payments, we're going to have kind of blown through the annuity and there's going to be no funds left over after 4 years. So I'm going to assume that our future value here happens to be 0. So the last thing we need to figure out is what should we take as n? Remember, n is t times f, where I want to use the frequency number associated with the payment structure. Yeah, so be careful. We want to actually program in n as 16. There should be 16 equal sized payments, not 48. We go through 48 compounds. Okay, let's try programming this into the calculator and seeing what we get for the equal sized payment. Yeah, sure. Megan, n is always t times f. N, when we're working with compound interest, tells me how many compound periods. But if I'm working with an annuity, I need to use the frequency number associated with the PMT, and n tells me the total number of equal-sized payments. Okay, so it's a bit of a slight difference between compound interest and annuities. That's correct, yeah. So we're using 4 here because the payment structure is quarterly, that's right. Okay, so I'm looking at the payment structure to get our F value for N. So that's probably something you want to make sure to write down on your formula sheet, right? So make sure on page 2 of your formula sheet, you're writing, N stands for the number of compounds. It's still calculated by multiplying T times F. We use the frequency number of the compoundings, to find n. When we're working with annuities, I can still calculate n by multiplying t times f, but we have to use the frequency of the payments, and then n stands for the total number of payments. So Fiona, there's no indication that there's going to be some money left over in the account. So yeah, we're assuming that after 4 years, we've withdrawn all of the money. We've accepted all of the possible equivalent payments that we can. So that's why we take FV equal to 0. In some questions, we might say like, hey, we'd like to have 16 equal size payments, but I want to make sure that there's still, I don't know, $10,000 left over in my account. I could ask that question, in which case FV changes a little bit. But we will deal with those questions after we're comfortable dealing with the basic cases. Okay, so CY is 12, PY I need to be 4. 12, so just let me kind of finish programming in. And yeah, 3,433.37, that sounds about right. Perfect, yeah, so that's what I get as well. Okay, perfect. So we've all been able to kind of verify that our equal sized payment, so our PMT should be $3,433.37. Did we agree on? Okay, nice. So if you're happy with that, let's talk about how we might tackle this from an algebraic kind of standpoint. So what if I, did have to utilize the formula? What is that going to look like? So the first thing we need to do is to calculate I2. So Laurel, is that, and that payment is quarterly times 4 years. That's where the n equals 16 comes from, yes. Yep, you're welcome, no worries. I know we're in a bit of new territory here, right? So ask all the questions to make sure you can kind of write little notes for yourself when you go to study. So because this is a general annuity, and if I want to tackle this in the algebraic way, the very first thing I have to do is make sure that the frequencies match up. So if I have a payment structure that's compounded quarterly, I also need my, if I have a payment structure that happens to be quarterly, I need my compounding structure to also be quarterly. Otherwise, the formula kind of breaks apart on us. So sometimes I list it like this. I list it like, what do I know? What's given to me? What's the rate that's given to me? The rate that's given to me is 4.5% compounded monthly. So that's the rate that's given to me. What do I want? Well, I would like to have a compounding structure that's quarterly. So Alexander has actually posted something in the chat that's actually really important and might be helpful for you to write down. So F1 always refers to the compound frequency in the I2 formula. And F2 always refers to the payment frequency in the I2 formula. Okay, that's how I always think about it. I always think about F1 as the compound frequency and F2 as the payment frequency. And once I know that information, now I can come back over here and start putting some values into this formula. So how do I get I1? Well, I take my 4.5% compounded monthly. And then F1 is 12. So we start with a monthly rate, and we'd like it to be a quarterly rate, so 12 divided by 4. So let's go ahead and try to calculate this one. And so I get a periodic rate that, yeah, is about 0.01129, pretty close to that number. Now, if I happen to need the nominal rate, I could multiply this by 4, but I don't need the nominal rate to finish this question. So I'm going to leave it as a decimal number. I'm going to leave it as I2. So the next thing that we need to do is go to our formula sheet and try to figure out what formula makes sense to use from the ordinary annuities section. Should I use the FV formula or should I use the formula for P? We'll deal with the formula for N probably next week on Monday. I think it makes sense to use the principal value formula, which is going to look something like this. And so in red, I'm going to go and I'm going to make the subtle change that we need to make to our formula in order to make it work. I just need to go everywhere where I see I. I'm going to change that I to I2. I said I2 too many times, didn't I? That was weird. So you change the I to an I2. And now we can substitute this number that we calculated directly in to where you have the highlighted terms. Okay, so to help us calculate PMT, we can input what we know our fair market value is. And we'll get something that looks like this. Okay, so I'll pause here just to make sure you can verify that and make sure that makes sense to you. And our goal is to solve for PMT. So what I'm going to try to do on the right-hand side is to simplify all of this. I want to make this one single decimal number. Once I have that decimal number, then I can divide 50,000 by that decimal number. Okay, good luck. May the force be with you. So I get a decimal number that's about 14.5629. I'm going to pause here, and you can let me know if you're able to verify that decimal number. If you are able to verify that decimal number, then we can do the division and prove to ourselves we should also get $3,433.37. Okay, so once we do the division, PMT should be 50,000 divided by this 14.5629. And we should be able to show that this is indeed $3,433.37. It's a good day, Laurel. What a good day, right? It's always nice when it works out. I find the principal value a little bit harder because you have to deal with the negative power and you have to deal with this like 1 minus 2. So you have to be really, really careful about evaluating this, this number. Okay, I'm just going to scroll up just to give us a little bit more room here to look at the next question. So it is 3:30. I might be able to sneak in the next 2 examples in the span of 20 minutes. We'll see how it goes. But I want to do a similar thing here. I want to try to solve this using the present value formula, as well as using the calculator. So just a lot of practice just to have lots of good examples in your notebook. So in this example, we have an interest rate that's 7% compounded semi-annually. And we'd like to figure out the principal value of a stream of $500 payments. These payments happen at the end of every 6 months. And let's see, payments occur for 5 years in total. Yeah, the first thing we want to do, like Fiona's suggesting, is try to figure out what kind of annuity we're working with. So we have semi-annual, and payments happen every 6 months. So semi-annual means 2 times per year. How many? So that's our compounding structure. Our compounding frequency is going to be 2 times per year. What's our payment structure? How many payments per year do we have? Yeah, there you go, Fiona. You got it now. This is going to be a simple annuity. Yeah, simple and ordinary. Yeah, you have to be very careful about the wording here. But yeah, this should be a simple, ordinary annuity. Yeah, and exactly correct. So this is I know because the payments per year are 2 and the compounds per year are also 2. So we have the simple case. That's quite nice. That means all I really need to do is go find my formula for the principal amount. I don't need to do any adjustments to the periodic interest rate I2. So I see Alexander's already muscling through on the calculator. You can verify our final answer on the calculator if you want. This one's not too terrible to actually use the formula, so I'm going to decide to do the formula first. Usually when I'm solving for PNT or I'm solving for N, that's usually when I use the calculator. It starts to get a little unruly. Okay, what do we got here? We have payment sizes of $500. And what do I need up here? 1 plus 7% semi-annually. And then the last thing we need to determine is what's going to be our power. So it's going to be a negative power. And we can find n by multiplying t and f together. Yeah, so 10 seems to be coming up a little bit, so I believe that's probably correct. So we have 5 years, 2 times per year. So yeah, I do agree with that. So 5 times 2, that should give us 10 payments altogether. Okay, so we're going to have a negative 10 as our power. So let's try to muscle through this one and see what we get for our present value. Okay, let's see, I have 10 payments, $500. So yeah, shy of 5,000. This seems like a reasonable final answer, but let me know what you guys get to. Let me know if you can verify my calculation. 415,830, great. So Fiona's able to verify. Yeah, Laurel, you got the same thing. Beautiful. All right, so if you are happy with that principal amount, you're able to get that number. Let's also try to figure out what kind of inputs we need for the calculator. Okay, so you're able to verify the number on the calculator as well, Alexander. That's great. Yes, Cranjit. Okay, great. So everyone's able to kind of verify that principal amount. Fantastic. These can be kind of tricky things to put into the calculator, so I'm proud of you guys. My face-to-face class had a really tough time today programming principal amounts into their calculator. Okay, so we have decided that there are 10 equal size payments. We have an interest rate of 7% compounded semi-annually. We are making payments during payments that happen at the end of every 6 months. So, I mean, arguable as to whether or not we'll put the 500 in as positive or negative. I don't think it really matters. In this particular case, we have a future value, let's say of 0, and we have 2 payments per year. So program that into your calculator and try to prove to yourself that the calculator spits us out $4,158.30. So that's kind of our final answer we're looking for on the calculator as well. We should be able to double check our answer and make sure we are happy with that. And I'm just going to roll up to our last example of the day. Laurel, you're able to verify it. Great. It's always nice when the calculator's working. It's a good day. It's a good math day when things work. All right, I got one last example just to help kind of clarify some of the steps we need to use here in the algebraic and the calculator way. So last example, we have payments that happen in a quarterly fashion, and the interest rate that we're getting is 5% compounded quarterly. Let's see, future value of the payment stream is $75,000. That's 10 years from today. We're going to determine the payment size. So Fiona's asking, is the payment, should it be negative 500? In this example, I don't think it matters. Are these payments coming into my wallet, or am I paying these payments? It's not really obvious in the statement of the question. So I think this would be a case where I would accept either positive or negative as the payment. Of course, if I put positive 500 in for the PMT, my calculator will give me negative 4,158. Fiona, just so you know. So yeah, if you want the PV to come out to be a positive value, we would input the PMT as a negative number. Yeah, you're right. Yeah, I guess you could say, we're making a $500 payment. Yeah, so I guess payment should maybe be negative. Like I said, I'm kind of like, it's not super obvious if it's going to be out of my pocket or coming to me. So I'm happy either way. If you use negative, that's okay. If you use positive, it really doesn't make a difference as long as we take the positive principal number, right? So if your number does come out to be a negative number, we'll just take the absolute value. Okay, I'm going to go ahead and I'm going to highlight the important terms and we'll try to figure out what kind of annuity we're working with. Even I don't know if it's going to be an ordinary or an annuity due without some more information. So let's just assume that it's end of quarter so that we know it's going to be ordinary. Yeah, so this will be a simple and ordinary kind of annuity because we have payments that happen quarterly and compounds that happen quarterly as well. It's an ordinary annuity because we're going to force the payment to be at the end of the quarter. And simple annuities are nice. That means I can just go right to my formula sheet and grab the formula from the ordinary annuities section without having to calculate I2. So I'm going to go and I'm going to take the future value formula. Alexander, that's correct. Yeah. So since F1 is equal to F2, you know it's a simple annuity. Yeah. I'm given some information about the future value of this annuity. So I'm going to use the future value formula to do my calculation. I know the future value is equal to $75,000. I don't happen to know the equivalent payment size. We're going to actually solve for the PMT. So let's go ahead and substitute our interest rate in of 5% compounded quarterly. And let's try to figure out what our value for N should be. Okay, so taking the frequency number, I think it's the same in this case. Yeah, so 40 seems to be coming up. So let's take a look. How we have 10 years and quarterly. Yeah, so I'm happy with that. 40 makes sense to me. All right, nicely done there, everyone. And then we just try to calculate this one, right? We try to simplify this one and make this bracketed number into a single decimal number. Good luck. May the force be with you. Yeah, nice. So that's what I get as well, Fiona. Nicely done. And then dividing these two numbers should give us the equal payment size. So I have two people saying $1,456.61. Perfect. Okay, not too bad. Gatika got the same, great. Excellent. So the last thing I want to do is just kind of work through what we would program into the calculator and allow you to double check that calculation as well. Okay, we've agreed on N equals to 40, 5% compounded quarterly. We know there's quarterly payments. Equivalent payments occur quarterly, and yeah, arguable as to whether or not we want the future value to be 75,000 positive or 75,000 negative. I think I would accept both. If we make FV positive, then the payment will come out to be a negative number and vice versa. So I'm going to go ahead, I'm just going to program these in just to verify our final answer here. And yeah, that looks good on my side. So of course I get a negative payment amount. If I take the future value to be 75,000 coming to me, then I'm going to have to pay into this bank account, and the equal size payments are $1,456.61. So beautiful. So I'm interpreting that negative sign as I'm paying out to the bank this amount of money every time. But the calculator does indeed verify that number for us, so we are good to go. That's everything I would like to show you for class today. Let's see, it is kind of like our Math Friday, isn't it? So I won't see you until next week on Monday. So everybody have a lovely weekend. Stay safe. Do a little bit of practice. Remember that assignment 3 is due this weekend, right? So Friday, I believe, is it Friday at midnight, I believe? Okay, so just be mindful of that one.
Brian, have you got time for a question?
Yeah, absolutely. What's up?
Yeah, I'm not quite understanding the concept of an annuity.
What's bugging you? Anything in particular, or just kind of like what it means in general?
I'm assuming what you're doing is purchasing an investment, and then you're deducting from it on a regular basis over time. Is that what, like, you're taking installments out of it?
Yes,
So it's gaining interest as you're taking money out.
that's correct.
Okay.
That's one way to think about an annuity.
And another way might be?
A mortgage, for example.
Okay.
So you've taken out a lump sum of money to pay for your house.
Mm-hmm.
And the bank account says, hey, you owe me this amount of money every month, but your debt still accrues interest over the span of time.
Okay, so it can be either way. An annuity can be either way. I was struggling with the wording sometimes in some of the problems in the book to totally get what was going on there.
Yeah, so there's like I said, there's a couple different ways you can interpret. Like an RRSP is another good example, right? Where you're kind of paying in every month and earning interest along the way. And then eventually you retire, and then it's kind of backwards, right? Now you're getting paid every single, every other month or every other week. So those are just different kinds of annuities. It just really depends on the setup of the question.
Okay, all right, that's fine. I think I was always thinking of annuity as being in one direction only. So some of the wording in the questions was then confusing me. So, and I was having trouble therefore of what is future value versus present value.
Oh, I see. Yeah. So if we're ever given like a fair market value today, that usually means we're walking into the bank, giving them some amount of money to invest for us and kind of getting these equivalent payments over time. Yeah.
Okay, that's the part I wasn't catching. Okay, thank you very much.
Yeah.
Have a good math weekend.
Yeah, you too, Laurel. Thank you.
Okay, bye.
Bye.